Hi everyone, hope you can see me and hear me well. So first of all, thanks a lot for everyone who joined. I see lots of friends, partners. So thanks for joining us in those crazy days. Um, Following what Mason just described, I will try to answer maybe some questions that rise in terms of security, and maybe to focus on some tax vectors and risks in STO, security tokens offering processes. And then we'll discuss how we approach it, how we solve those issues together with the TokenSoft and partners. So let's deep dive, not too much, not to do it too detailed, but let's go into it. So as Mason mentioned, the processes becoming regulated and complex. So there are certain roles, owners, admin, investors. There are lots of functionalities like KYCs and whitelisting. It's a way to make sure the public address of the investor go to the blockchain. There is a lot of functionality related to token supply management. You can burn, mint, revoke. So there's a lot of functionality and lots of phases, starting from the smart contract deployment and ending in the token distribution phase. So lots of processes, lots of complexity, adding to it the needs for automation and scaling, increasingly raising the bar for cyber attacks and private key breaches. So as you can imagine, cold storage or offline solution are not valid in those use cases when you want to be enable automation and scaling. So there is a different approach, a different requirements to enable one, private keys secured, but both you want it to be online and available whenever you need it. So the issue is, of course, what happens if a hacker goes and get access to those private keys. So eventually he got full control over your business. And it's that's something that might be devastating. Let's take, for example, a smart contract deployment phase. So it's basically like you are writing a code, a software that manages all your business. So it's like you are building a software for to flight an airplane, so cruise control, and you want to be 100% sure that from the moment you wrote the code, you tested it, you verified it, you sign it, you want to be 100% sure that that software went into the airplane, and if someone in the middle tampered it or changed even one bit, the plane can crash. So it's much of the same here, but with the blockchain. So there is the data, there is the code that needed to be verified, compiled into binary, and being signed. And that process is extremely sensitive and can harm the business critically. So this is one huge risk in the process, and all those processes, the KYC, the token supply management, are eventually finished in private keys that sign data that goes to the blockchain, the smart contract. So this is one. Second risk, or second vector attack, is fraud. So most of the hackers or sophisticated hacker will not go straight to hack the private key, because most of the organizations, such as banks, know how to protect those pretty much good. So what they will do in the attack vector will be to get access to the authentication keys, literally steal the identity of the owner or the administrator of the STO platform. And what they will do now, they will be able to generate a falsified transaction, build it as their own, and generate it through the approval and process from the server or from the laptop of the user through the whole process and to the blockchain. And no one will stop it because you have the authentication keys. So that's what will do a hacker, which is not so sophisticated. The sophisticated one will get into the network and they will try to understand the policies of the company, the signing rules, or the authorization flows. And once they land it, because usually those policies and rules are kept on non-secure servers, PCs on the cloud, which is known as non-secure. So what the hacker will try to do is to, in one case, he will try to build a transaction that will bypass the policies and the rules. And then he can build like thousands of small transactions to bypass and go under the radar. Or he will try to do a forgery of the policies and do it worthless and be able to steal all the digital assets. So in terms of hacker having access to those authentication key, think of a use case that he can open a fake client with a fake public address. And he can control the supply management of the token. He can change ownership and transfer tokens from one account to another without anyone even to know about it. So it's a huge problem from the cyber perspective and the company as a brand. So let's see how we approach to those risks and what do we do in order to solve it. So basically, as a statement, when we are approaching to analyze the cybersecurity threats and to provide solution, we basically assume that the network is hacked. So it's not only the network, it's the PCs, it's the cloud, it's the mobile devices. We don't trust any external software or commercial hardware, which is not our dedicated hardware. So that's as a basic statement, and that's what we see happen every day. Today it takes 19 minutes to professional hackers group to get access into a connected network, get access to the security keys, the private keys, the assets, and get away with the funds. So that's what it takes, 19 minutes. So basically everything today is hacked. So when dealing with the private key security, and you want to be able to enable availability for the automation and scaling, the keys must be always in rest or in a process. They must be in a dedicated environment, secure environment. It can be HSM or other environments. The HSMs, of course, bring the higher level of security, but it depends on the risk you have. So what we are doing, we are generating the keys inside our HSM. And then the keys always process inside the HSM. So all the data, the information for the STO process needs to go through an API from a backend or from an endpoint device to the HSM to be filtered, verified that there are no hackers trying to hack it, digitally verified, and then, only then, the message will get inside the HSM to get access to the private key, and from then to the blockchain. So this is one. Second, extremely important is if you know how to detect cyber threats. So you need two things. One, to detect the cyber threat and respond immediately to eliminate risks. It goes for remote attacks and for physical attacks. So you want to be sure that if someone's trying to hack your devices or to open them, radiate on them, do whatever it's trying to do in order to get access to the keys, or even trying to burn a new code inside your device, you need to be able to detect it and eliminate the risk. In our case, we are not just wiping the keys to make sure no one gets access to the secrets. We are physically burning the chips. So we are taking it to the extreme. In use cases that needed it, we can verify that no one, even if it's open the enclosure, can get any leftovers of keys that were wiped. So it's a total burn. And that's something unique we are doing these days. Second issue is fraud, as we discussed before. So here there are several things. One, because we don't trust anything that runs outside of our devices, we cannot trust backends, we cannot trust mobile application. So how to prevent remote access to the authorization keys? So we keep those keys inside our small device, which is handheld device. We called it a mini HSM. It's a miniaturized hardware secure module, which enable two major things. One, we know for sure that the key is always in a dedicated hardware, which is separated from the internet or hacked devices or non-secure devices. So all the processing with those authentication keys goes inside the mini HSM. And secondly, to prevent fraud, we can make sure that what is seen on the small screen, the secure screen, this one, is eventually secured, and that's the data that at the end of the process will go to the HSM and to the blockchain. So for example, in STO process, if there is an owner that would like to, or issuer that would like to do a very sensitive operation like revoke or burn tokens, so he would be able to use that device, which is always connected through mobile devices or through PCs or other networks, securely to generate a secure message to the HSM. That's way how we verify that there is no man-in-the-middle attack. No one from the external network can change the data because the identity keys are kept inside the hardware. And point number 3, it's the policies and the rules. So as discussed before, it's not enough to have policies and rules in a non-secure server. What you need is security. So a hacker is trying to understand and learn the policies and the rules and trying to go beneath the radar or change them. What you need here is to secure it in the highest manners. We are securing the policies inside our HSM secure enclave. So that's how we can verify that no one externally can even view the rules, and the modification of the rules can be done only by an administrator that have access through the mini HSM device. So it's an end-to-end security. In order to see the rules and to modify them, you must have the identity keys that are kept in the mini HSM device. And maybe to put everything together, that's how we protect the flow. And we enable the automation from one point. We enable the availability. So the blockchain private keys are always kept in the HSMs, never leave it. The policies and the rules are also inside the HSM. Thus, we provide a secure access and secure on-ramp to the blockchain. So all the call functions, all the smart contract deployment, everything runs from the HSM with the private keys to the blockchain, and information from the STO manager or TokenSoft company in that specific case, everything which is need to be visually verified or sensitive messages can be generated from the mini HSM device. So STO admin or the token issuer can now have a secure connection between hardware to hardware, and he can verify any bit and byte that goes eventually through the HSM to the blockchain. So in that case, you can be 100% sure that the message that you sign as an administrator or owner is generated online without any fear or man-in-the-middle attack that can happen. That's how we enable the process to be also automated, secure, and available. So maybe to put it in a broader spectrum, so we've built general purpose devices, one for the client side or the administrator side, and one to the company side that holds the assets or the keys. Everything is connected. Everything can be run through mobile devices like we are all living today. You know, in quarantine days, we see bank managers or company officers working from home without any real secure measurement. So that's what we can deliver for many use cases, from blockchain and digital assets to standard KMS, PKCS11 functionality that needed in the cloud. We're even using our platform and building it to secure gold transaction, as much as it sounds interesting. That is for my side. Back to you, David.